Hello, in today's lecture we are going to discuss about the chapter Aldehydes and Ketones. So basically aldehydes and ketones we call they are the organic compounds. So the question here is what is meant by the organic compounds. So in chemistry we divide inorganic chemistry and organic chemistry as well, the physical, industrial, like that. So the difference between inorganic chemistry and organic chemistry, that is depend on their sources and the composition. So inorganic chemistry or inorganic compounds that we classified on the basis of their occurrence, that is, so inorganic compounds we get from the nature, that is from the non-living things, that is from the earth crust, and the organic compounds we get from the nature only, but the difference is from inorganic compounds. So here the organic compounds we get from the living things, that is the animal or the plants, and on the basis of composition we classify the inorganic uh, compounds and organic compounds. That are the organic compounds we called hydrocarbons. That means the molecule or compound is made up of the high percentage of the carbon and hydrogens, so that the name hydrocarbons. So other than the hydrogen and carbon, the compounds we call they are the inorganic compounds or inorganic elements. So this is we classified the inorganic compounds and organic compounds on the basis of the occurrence and the composition. So in nature the aldehydes and ketones we can find in the plants as well as the animals. So some of the examples just want to give that are, so we already know about the carbohydrates. Yes, carbohydrates are the fructose, glucose, maltose, etc. Yes, so glucose also we called, that is aldo sugar, that is because of the presence of functional group aldehyde, and fructose that we called keto sugar, that is because of the presence of the functional group, that is the ketone. So there we can find the aldehydes and ketones in fruits and as well the flowers, and also we can find the aldehydes and ketones in animals also, that is for example vitamin A that contain aldehydes. So these are the basic regarding the aldehydes and ketones, that is their sources. Then aldehydes and ketones are organic compounds which contain carbonyl groups. So if you see in the structure of aldehyde and ketones, that contain common a functional group, that is the C double bond O, that is nothing but the carbonyl compounds. So that these aldehydes and ketones collectively we call they are the carbonyl compounds, that is because of the presence of C double bond O. Then the aldehydes are the carbonyl compounds we collectively called aldehydes and ketones, they are carbonyl compounds, that is because of the presence of C double bond O. So that the aldehydes are the carbonyl compounds which are represented by a general formula R C double bond O H, where R is an alkyl group or hydrogen or the aryl group. So in general we represent the aldehydes is like R C double bond O H. Here the functional group of the aldehydes is CHO. Yes, so this is the aldehydes. So aldehydes are carbonyl compounds which are represented by a general formula or CHO, where this R may be a hydrogen, may be a alkyl group, or may be a aryl group. So some of the examples we can see in here. The first one, that is R here is, that is the H, example is formaldehyde, and R is CH3, example is acetaldehyde, and R is aryl group, that is the example is benzaldehyde. So this is regarding aldehydes. The next is ketones. The ketones are the carbonyl compounds which are represented by a general formula R C double bond O R dash. So there in aldehydes we represent generally R C double bond O H, but here in ketones we represent in general that ketones are R C double bond O R dash, where R and R dash are alkyl and aryl groups. So here R, that doesn't be a hydrogen. So R and R dash should be alkyl group and aryl group. So the functional groups here is, we consider C double bond O. So examples, that is the acetone, acetopenone, benzopenone. So here both R and R dash are alkyl groups. One of the R is CS3 and one of the R is benzene group. So these two are aromatic ketones, and this example is for the aliphatic ketone. So aliphatic aldehydes and ketones, they have general formula CnH2nO. So generally we represent aldehyde and ketones, that is CnH2nO. The presence of common carbonyl group in two classes of compounds makes them display a similar chemical properties. That means both in a ketones and aldehydes we can find the carbonyl groups, so that both the molecules, they can display or they can show a similar chemical properties. That may be a reaction. Aldehydes are more reactive than ketones because of the presence of free hydrogens. So here if you compare the reactivity of aldehydes and ketones, so aldehyde is more reactive than ketone. That is because of there in ketone one of the extra CH3 group that is present besides the C double bond O. So that bit decreases the reactivity of the carbonyl group as compared to aldehyde. Then an aldehyde group should be present always at the end of the carbon chain. A ketonic group cannot be present at the end of the chain. Hence, minimum number of carbon atoms required to form a ketone is 3. This means, so in aldehydes we can find the functional group that is present always at one end, that is in a aldehyde. But in ketone, that functional group, it not present at the end of that molecule. So it should in between the molecule of the ketone, so that the minimum number to form a ketonic molecule, that should be a 3. So some of the examples for both aldehyde and ketones, that is this molecule is acetaldehyde, this is propanaldehyde or propanal also we call. In nomenclature we can discuss about that. This is acetone, this is butanone. Yes, so this is regarding the definition of the aldehydes and ketones. Then next point is, that is the nomenclature. So IUPAC nomenclature for aldehydes are obtained by replacing the ending E of the corresponding alkane with Al. So here, so in naming the aldehydes and ketones, so we named the corresponding alkanes. For example, if you name the acetaldehyde, that is acetaldehyde is a common name, but this a CH3CHO, that is IUPAC nomenclature for that molecule or that compound is ethanol. Ethanol. So ethane or eth, it is nothing but the organic compound containing two carbon molecules. So ethanol, that is the IUPAC nomenclature for this molecule. So that came from the corresponding alkane, that is the ethane. So there we replaced, that is end E by Al. So that become the IUPAC nomenclature of, or IUPAC nomenclature of that particular aldehyde. So some of the examples we can see in here. The first one, that containing only one carbon atom, so that is a methanol. So one carbon atom containing aliphatic hydrocarbon, that is the methane. So here we replace E by Al, that become an IUPAC nomenclature for the aldehyde. The second molecule containing two carbon atom, so that in aliphatic hydrocarbon, that is the ethane, but the IUPAC nomenclature of this molecule is ethanol. Similarly, propanol, then 3-methyl butanol. So here in numbering the position of the carbon atom, here the numbering start from the carbon atom, that is carbon atom, that is from the functional group, that is CHO. So 1, 2, 3, 4. So that the IUPAC nomenclature of this molecule is 3-methyl butanol. Butanol is because of this molecule straight chain containing total 4 carbon atom. Then second is the IUPAC names for ketones are similar like aldehydes. Here we replace the ending E of the corresponding alkane with -one. So there in aldehyde we replace E by Al, al, but here in ketones we replace E by -one, that is the ONE. So the chain is then numbered. So after replacing the E by -one, the chain is then numbered to give the carbonyl carbon the lowest possible number. So in example we can see that. So here first example, that is the ketone molecule containing 3 carbon atom. So in aliphatic hydrocarbons, the 3 carbon containing molecule we called propane. So here we replace E by ONE, so that the name of this molecule is propanone. But the common name for this molecule is acetone, but IUPAC name for that molecule is propanone. Then the second molecule is here. So we can start numbering the carbon atom from this carbon atom. That is because of this carbonyl should get lower possible number, so that this carbon gets the first position 1, 2, 3, 4. So that the IUPAC nomenclature or name of this molecule is 3-methyl butanone. Butanone is because of this molecule contain totally 4 carbon atom. So this is about the nomenclature of, that is IUPAC nomenclature of aldehydes and ketones. Then next point is, that is the preparation of ketones. Means preparation of aldehydes and ketones by using acid chlorides and nitriles. Well, so first one, that is the preparation of aldehydes from acid chlorides. So acid chlorides or acyl chlorides undergoes hydrogenation in the presence of catalyst such as barium sulfate or palladium, that is PD, barium sulfate or palladium, to form aldehydes. So that is in the presence of sulfur or quinolone. So these sulfur and quinolones that helps to stop the reaction at aldehydic position only. So that doesn't let that aldehydic molecule further oxidation into an carboxylic acid. So that is the help of sulfur and quinolone. So that is the first one, preparation of aldehyde from acid chlorides. So acid chloride or acyl chloride undergo hydrogenation in presence of catalyst such as barium sulfate or palladium in the presence of sulfur or quinolone. So that gives a product aldehyde. Yes. So this reaction we called Rosenmann's reaction. So you can see in here the reaction. In general, I have taken here, that is the acyl chlorides. Yes, that means the acid chlorides. So this reaction that is nothing but the hydrogenation reaction that takes place in the presence of a catalyst, palladium or barium sulfate. So that hydrogenation is nothing but the addition of hydrogen to this molecule. So here the overall reaction that takes place, the replacement of the Cl by hydrogen, so that gives the product aldehyde. So this is the preparation of aldehydes by using acid chlorides. So here the R may be a hydrogen methyl group, or it may be a vinyl group or aryl group. So this is a preparation of aldehydes by using acid chlorides. So that we called Rosenmann's reaction, that is nothing but acyl chloride, that hydrogenation in the presence of palladium or barium sulfate that gives the product aldehydes, the presence of sulfur or quinolone. So here the sulfur or quinolone that helps to stop the reaction at this product only. It doesn't let the further oxidation of aldehydes into an carboxylic acid. So this is about the preparation of aldehydes from acid chlorides. Then second preparation of aldehydes is from nitriles. So it undergoes reduction of nitriles with stannous chloride in the presence of HCl. So we know the reduction is the converting double or triple bond into a single bond. So that we called the reduction. Yes. So here reduction of nitrile groups takes place in the presence of stannous chloride by stannous chloride in the presence of HCl. Here SnCl that SnCl2 that act as an reducing agent. Then it leads to the formation of corresponding imine. Yes, if that depends on, means corresponding here, that depends on R group. So nitrile, after reacting with the SnCl2 reagent in the presence of HCl, that gives imine. So imines are nothing but C double bond NH molecules we call imines. So after formation of imines, further hydrolysis that yields the corresponding or particular aldehyde molecule. So this we call Stephen's reduction. So here the second preparation of aldehydes from nitriles is, so it undergo reduction of nitriles with SnCl2 in the presence of HCl. So leads to the formation of corresponding imines. Imines are nothing but C double bond NH. This imine further hydrolysis that gives the corresponding aldehyde. So this we call Stephen's reduction. So this is the reaction, that is nitrile after reacting with stannous chloride in the presence of HCl. So that converts the nitriles into an what? The imines. So here reduction takes place, that means conversion of triple bond into an double bond. So this after hydrolysis that gives the aldehydes. So here R may be a hydrogen, maybe a CH3, maybe a pH. So that we used the word corresponding imines and corresponding aldehyde. If the R group is H, then product that we get, that is the formaldehyde. In case if the R group is CH3, we get the aldehyde, that is the acetaldehyde or ethanol. Next is the preparation of ketone from acid chlorides. So here acid chloride, after reacting with dialkyl cadmium, so that gives a corresponding ketones. That means, so acid chlorides after reacting with dialkyl cadmium, I have taken here the general reaction. Acid chlorides after reacting with dialkyl cadmium, that gives corresponding ketones with the elimination of byproduct cadmium chloride. Yes, so here R should be an alkyl groups, alkyl or aryl groups, and R dash should be alkyl or aryl group. Both R and R dash should be alkyl and aryl groups. So here R and R dash shouldn't be a hydrogen. Yes, so this molecule is a ketone. So nitriles after reacting with dialkyl cadmium, so that gives a ketones, that is the corresponding ketones by the elimination of cadmium dichloride. So second preparation is from nitriles. So nitriles after reacting with Grignard reagent, so followed by hydrolysis, that gives the ketones. So here, so directly I have taken the example of, that is methyl cyanide, that reacting with benzyl magnesium bromide or vinyl magnesium bromide, also we called benzene magnesium bromide, that is the Grignard reagent in the presence of ether. So that gives magnesium bromide substituted imine. Yes, that is the Grignard reagent substituted imine. So this after hydrolysis, that gives a product that we call ketone. So here ketone that formed is methyl vinyl ketone. So nitriles, that is the methane cyanide, after reacting with Grignard reagent, that is benzene magnesium bromide or vinyl magnesium bromide in the presence of ether. So that gives an intermediate product imine, that is a substituted imine. So this substituted imine after hydrolysis, that gives a product that we call ketone. So this ketone is methyl vinyl ketone. Yes, so this is regarding preparation of ketones from the acid chloride and nitriles. The next point is, that is mechanism of nucleophilic addition reactions. So if you consider the carbonyl group, so in carbonyl group, oxygen is more electronegative than the carbon. So electronegativity is nothing but here the atom that have the ability to attract a bonding electron towards itself. So because of the more electronegativity of oxygen as compared to carbon, so this oxygen that takes this pi bonded electron towards itself. So due to the resonance or due to the electronegativity difference, so this molecules or that oxygen gets the partial negative charge and this carbon gets the partial positive charge. That shows the oxygen is more electronegative than carbon. So carbon that has the possibility to get, or that has the possibility to form carbocation. So carbocation is nothing but carbon with electron deficiency. So nucleophiles can attack carbon atom of carbonyl group. That is because carbon here that act as an carbocation. Nucleophiles, they are carbon anions. So carbon anions, they are electron rich centers carbocation is electron deficient center, so that nucleophilic attack that takes on the carbon atoms. Therefore, carbonyl carbon group can undergo nucleophilic addition reactions. So because of the electronegativity difference between carbon and oxygen, so the carbonyl group that undergo the nucleophilic addition reactions, that is because carbon gets the positive charge that acts as an carbocation, and nucleophile is electron rich, so that it can undergo the reaction with carbon, that is the electron deficient center. The first example we can see in here, that is the addition of HCN. HCN is nothing but hydrogen cyanide. The general reaction I have taken here, that is RC double bond OR dash after reacting with HCN. So here HCN, if you consider hydrogen and cyanide electronegativity, cyanide is more electronegative, so that it gets the negative charge. Hydrogen is less electronegative, so that it gets the positive charge. So cyanide that act as an, cyanide means Cn minus that act as a nucleophile here. So nucleophile that can attack on carbonyl group, carbon of the carbonyl group. So that results the formation of cyanohydrin. So addition of HCN takes place to an carbonyl group of aldehyde or ketone that gives the product cyanohydrin. Examples. So if you react the acetaldehyde with hydrogen cyanide, we get the product that is acetaldehyde cyanohydrin. So this overall addition reaction that takes place in the presence of base catalyst. So catalyst, the definition of catalyst we all know. So catalyst is nothing but it is a chemical compound that helps to proceed the reaction without involved in the reaction, means without change in their chemical nature, so that helps to proceed the reactions. So acetaldehyde after reacting with hydrogen cyanide, it gives the product what? Acetaldehyde cyanohydrin. So that is in the presence of base as a catalyst. So its mechanism we can see in here. The next example I have taken is the ketone. Acetone after reacting with hydrogen cyanide, so that gives what? Acetone cyanohydrin. So overall, aldehydes and ketones after reacting with addition reaction, means that after undergo addition reaction with hydrogen cyanide in the presence of base catalyst, so that gives acetone cyanohydrin, that is the product. So mechanism we can see in here, that is, so first step that involved is nucleophile formation. So that hydrogen cyanide after reacting with the base catalyst, that is the hydroxide ion, so that form the cyanide ion. So this molecule that acts as a nucleophile, that is because of negative charge on cyanide ion. So this molecule or this ion is an electron rich center. The second step is the attack of cyanide ion on carbonyl group. That Cn minus after attacking on carbonyl group, that gives a negatively charged oxygen anion intermediate. That is cyanide substituted negatively charged oxygen anion intermediate. So in the third step, this intermediate after attacked by the H plus ion from this water, so that gives the final product what? The cyanohydrin. So first step, that is the nucleophile formation, that is by the base catalyst, so that involve the formation of cyanide ion Cn minus. The second step, that cyanide ion attack on carbonyl group, that gives the intermediate product. This intermediate product after attacked by H plus ion from the water, so that gives the product cyanohydrin with the elimination of OH minus. So OH minus that act as a catalyst here, So in the initial we used the OH minus. After the completion of reaction, that exit or that left the reactant molecule as their original pore. So that this we call catalyst but not the reagent. Yes, this is regarding about the addition of HCN to an aldehydes or ketones. The second reaction is that is acetal formation reaction. So this acetal formation reaction takes place after the addition reaction of alcohol takes place to an aldehydes and ketones. So in general I have taken here the RC double bond OR dash after reacting with the alcoholic molecule. The first molecule means after reacting with first molecule of alcohol, it gives hemiacetal or hemiketal that depend on the reactant molecule we used. In case if we use the aldehyde, the product is hemiacetal. In case if you use acetaldehyde, the product is hemiacetal. If we use the reactant molecule ketone, the product is hemiketal. So this hemiacetal or hemiketal after reacting with second molecule of alcohol, so that gives the product of the acetal or ketal with the elimination of water molecule. Yes, that mechanism we can see in here. The aldehyde or ketone or so this reaction undergo in the presence of acid catalyst. So there the addition of HCN that undergo in the presence of base catalyst. This reaction undergo in the presence of acid catalyst. The carbonyl group that may be aldehyde or ketone after reacting with H plus that is a proton, it gives what? The carbocation. Means here the acid that helps to convert the carbonyl molecule into an carbocation. Yes. So this carbocation after reacting with the first molecule of alcohol. So here the reaction undergo between carbocation and the first molecule of alcohol is because this carbon that act as an electron deficient, and in alcohol we can see the oxygen that have the lone pair of electron, so that act as an what? Electron rich center, so that the reaction undergo between carbocation means carbon and the oxygen of this alcohol, so that gives the intermediate product. So here oxygen got the positive charge is because so this oxygen that shared lone pair of electron with the carbon atom, so it loses its one lone pair of electron, so that it gets the positive charge. In further reaction, this oxygen eliminate that hydrogen that is bonded hydrogen as a H plus, so that here this hydrogen that eliminate as a H plus, that H plus attack on another OH minus present in that molecule. So this is the possible site to attack this hydrogen, means that hydrogen is electron deficient. That is because that hydrogen is eliminating as a H plus from this group. So this H eliminate as a H plus, then this H plus attack on this OH group. So that the next step we can see in here the OR double dash and the red H I represent here that hydrogen that came from this molecule or this position. So that become OH2. That is because O again loses its one of the lone pair of electron, so it gets the positive charge. Then in the further step, this H2O that eliminate from this molecule as a H2O means this molecule that eliminate from the whole molecule as a H2O, so that left with carbon with a positive charge. That is because this oxygen takes bonding electron with the carbon atom. so that it gets the C positive that we called carbocation. Then at this position, the second molecule of alcohol that attack on this carbon cation. So that gives a substituted the intermediate molecule, and from this step the elimination of H takes place. So that gives the final product, that is the acetal or ketal. So the overall mechanism is, first the aldehyde or ketone that react with H plus, that gives the carbocation. So after formation of carbocation, the first alcoholic molecule react with that carbocation. Thereafter, the elimination or transfer of hydrogen that takes place, H plus from alcohols to the hydroxyl group, that results the elimination of H2O. So that results the formation of second carbocation, that is it here. So at this position, the second molecule of alcohol that attack on this molecule, the further the elimination of H plus, that gives the final product acetal or ketal. So here initially that H plus helps to form the carbocation. So after the reaction, that eliminate as a H plus. So the acid that act as an catalyst here. Example, so if we used acetaldehyde with 2 molecule of ethanol in the presence of HCl catalyst, that gives the product acetaldehyde diethyl acetal. Yes, that is the acetal molecule. In case if you used the reactant molecule is acetone, that is the ketone, the acetone after reacting with 2 molecule of alcohol in the presence of HCl, so that gives the product acetone diethyl ketal. If we use aldehyde, the product is acetal. If we use ketone, the product is ketal. So this is regarding about the second addition reaction, that is the alcohol, that is formation of acetal or ketal. Next reaction is reaction with sodium hydrogen sulfite, that is NaHSO3. So when aldehydes and ketones after reacting with sodium hydrogen sulfide, so that gives the sulfite substituted intermediate product. This after proton transfer, that gives bisulfite addition product. So this is a reaction of aldehyde and ketones with sodium bisulfite. So sodium bisulfite after reacting with aldehydes or ketones, so that undergo intermediate, that gives intermediate product, that is the sulfite substituted intermediate product, that is bisulfite substituted intermediate product. This after proton transfer, that gives the product, that is bisulfite addition product. So example is, if we use acetaldehyde, this acetaldehyde after reacting with sodium bisulfite, so that gives the product acetaldehyde bisulfite addition product. So this is the name of this molecule, that is this is nothing but a sulfite substituted reaction. So aldehyde after reacting with sodium hydrogen sulfide, so that gives the sulfite addition product. Yes, the name of this product is acetaldehyde bisulfite addition product. Then the ketone after reacting with sodium bisulfite or sodium hydrogen sulfite, this gives acetone bisulfite addition product. Yes, so this is acetaldehyde bisulfite addition product. This molecule is acetone bisulfite addition product. So this is reactions with or reactions of aldehydes or ketones with sodium hydrogen sulfide. So aldehyde or ketones after reacting with sodium hydrogen sulfide, it gives intermediate product. This intermediate product after proton transfer, it gives a bisulfite addition product. So if the reactant molecule is acetaldehyde, so product is acetaldehyde bisulfite addition product. If the reactant molecule is acetone, the product is acetone bisulfite addition product. So this is about the reactions of aldehyde and ketones with sodium bisulfite. The next is the reactions with NH2G derivatives. Yes, so here NH2G derivative, it in this molecule G, that may be a hydrogen, that may be a alkyl group, that may be a aryl group, that may be a OH, or that may be a NH2 group. So these are the derivatives of NH2G. So this aldehyde or ketone after reacting with NH2 derivatives, so in general I given here the reaction, the NH2G after reacting with aldehyde or ketone, that gives this product, that is the C double bond Ng product, the elimination of water. So I have taken the next is the example, that is in case that G is hydrogen, the whole molecule is become a NH3, that is ammonia. When ammonia after reacting with aldehyde or ketone, the product is imine, that is C double bond NH group is, the product is imine. If the G group is alkyl group, that is the CH3 group, the product is substituted imine. If the G group is aryl group, that imine is aryl substituted imine. Here alkyl substituted imine, this product is aryl substituted imine. In case if that G group is OH, this molecule is hydroxylamine, the product is oximes. If that G group is NH2, the whole molecule is hydrazine, the product is hydrazones. Yes, so this is reaction with NH2G derivatives. So G, that may be a hydrogen, alkyl, aryl, OH, or NH2. In case the G is hydrogen, after reacting with aldehyde or ketone, the product we get is imine. In case if that G group is alkyl or aryl group, the product is aryl or alkyl substituted imine. In case if that G group is OH group, the product we get is the oximes. If the G group is NH2, the product we get is hydrazones. So one of the reaction I explained with mechanism, that is the reaction with the hydroxyl amine. Yes. So well, hydroxylamine is nothing but NH2OH. The aldehydes or ketones after reacting with hydroxylamine, they form oximes, that is the corresponding oximes. In case if the reactant molecule is acetaldehyde or aldehyde, the corresponding product is aldoxime. In case if the reactant molecule is ketone, the corresponding product is ketooximes. So overall, the aldehyde or ketone after reacting with hydroxylamine, the product we got or we get is oximes, the elimination of water. So these reactions involve the mechanism that is in the presence of acid catalyst. So here general reaction I have taken here, the RC double bond OR dash after reacting with H plus, that involve the formation of carbocation. This carbocation in the second step after reacting with NH2OH, that form the NH2OH substituted molecule. This we called intermediate. So intermediate molecule that not have a common name as well as the IUPAC nomenclature. So the nitrogen, we know that it has lone pair of electron. So this lone pair of electron after attacking on the carbocation, that is because of carbocation is a electron deficient center, the nitrogen is electron rich center, so that undergo the reaction between nitrogen and carbon, so that gives N substituted intermediate product. In the third step, so here after losing its one of the lone pair of electron, nitrogen gets the positive charge. So this nitrogen regets its lone pair of electron by eliminating one of the hydrogen. So that eliminated hydrogen that attack on the OH group. So that we can see here the next step, OH to NHOH. So this plus charge convert into an lone pair of electron by this nitrogen gets the bonding electron from this hydrogen. So hydrogen that eliminate from this site as a H plus, so that H plus attack on OH group, so that convert into an OH2 plus. Further, the elimination of water molecule, that is why this nitrogen means after eliminating the water molecule, this carbon gets the carbocation, means this carbon gets the positive charge. At that time this nitrogen that shared the NH bonding electron with this carbon, so the lastly the elimination of H plus, that gives the product oximes. So here R and R dash may be hydrogen, CS3 or pH. Once we'll discuss this reaction, that is a reaction with hydroxylamine, aldehyde or ketone. After reacting with hydroxylamine, the product is oxime, that is the corresponding oximes. First step involve the formation of carbocation. The carbocation after reacting with hydroxylamine, that gives N substituted intermediate product. So here the proton transfer takes place from N to an OH. So that results the elimination of H2 molecule. Then the further shifting of the hydrogen bonding electron with carbon and nitrogen, that gives the product oximes. So example, the reactant molecule is acetaldehyde, the product is acetaldoxime. The reaction molecule is acetone, the product is acetoxime. So this is about the reactions of aldehydes or ketones with hydroxyl amine.